All right, welcome everyone. Now the Kalmar's webinar series continue with eco-efficient RTGs and smart choices and hybrid options. My name is Marko Rosinen. I've worked at Cargotec for about 20 years now in engineering, sales, product management roles. My current position is product manager. Let's check some practicalities first. So during the presentation, all you participants are automatically muted. If you have any questions during the presentation, please type and send the questions to all panelists in the chat window. If you experience any network issues or technical breaks or problems, no worries. The webinar recording will be sent to you afterwards later this week. Let's check first the agenda. We start with basic crane design and see how the choices there affect the eco-efficiency of the cranes. Then we take a look at the Kalmar RTG power source alternatives, having a close look at the Kalmar hybrid RTG, and also introducing the zero emission RTG with battery pack. As last item, we go through a customer case, which is Exelgan in Argentina, who have our hybrid RTGs in operation. And we learn about their experiences with our cranes. And at the end, we have a Q&A session. So if we try to answer your questions there, and if we don't have enough time, maybe we will then answer them in writing separately. Okay, we start with the crane design and the choices there, how it affects the eco-efficiency. We feel that improving environmental performance at container terminals is very, very important. There are actually many choices that affect sustainability when buying new equipment or retrofitting the existing ones. Typically, we are talking about electrification here, but there are also several other good options for diesel-powered machines as well. Also, big impact can be achieved paying attention to some design details. We at Kalmar have been doing a lot of work for years already to be able to improve the eco-efficiency of our products. RTG is a very good example of this one. We were the first ones to introduce the E-RTG with cable reel already about 20 years ago. And we have introduced since a lot of alternatives for energy supply of our cranes. We are proud to share here our learnings. When I started with Kalmar, the only alternative we had was a single speed generator with a few supplier options, but that was more than 20 years ago. In the coming slides, I share you with some technical details and power supply options that we have found out to have a big impact on the power consumption. We have real life experience on all of these, therefore we can help you in finding the best possible setup for your needs. So in the next slides, we will cover these design issues affecting the eco-efficiency, starting with the structural design, basically the crane weight. We cover the all-electric versus hydraulics systems, impact on the weight of the spreader headblock combination, the lighting setup, how is the difference between variable speed generator or constant speed generator, and furthermore, if we use an optimized variable speed generator, in lieu of a full-size variable speed generator, and also cover the battery hybrid. Okay, starting with the structural design, basically the crane weight. So with high quality steel, of course, the steel structure can be better optimized. And one good design principle is also the design simplicity. Less parts, less components means less weight. The potential saving with this kind of things is about 0.5 liters or 0.13 gallons per hour. Typically, the RTG weight range is from 120 to 180 tons. So they're the different comps. Of course, this 0.5 liters depends on how much gantrying you do, for example, but it's like a good average. And this lower weight has naturally other positive impacts, like lower crown pressure and cheaper civil works on the crown. Choosing all-electric design over hydraulics has an impact on the energy consumption as well. Traditionally, the hydraulics have been used in spreader, wheel turning, micro movement, etc. But opting for electric motor-driven solutions can save even up to 2 liters per hour, depending quite a lot on the amount of hydraulic systems you have or how their actual operating principles of these systems are. And and also the electric design affects the reliability, lower maintenance, things like that. So it's only also other positive impacts. Then one very important area is the spreader weight, as it's lifted in every container handling cycle at least 2 times. So the typical weight of the head block spreader combination varies from 7 tons to 16 tons. So there's a big variation there. And say here that the 1 liter per hour potential saving, but it can be actually more if you think about if you are using if your operation is like very hectic and you do a lot of movements. So the 1 liter corresponds to 0.26 gallons. Also, the lower lifted load is it affects quite a lot on the structure as well. So less stress on the structure, the lower lifted load, less stress on the structure, and lighter structure. So in that way, it also affects the total weight of the crane and also affects the fuel consumption in that way. So it's like a chain reaction in a positive way. Okay, then about lighting setup. Choosing LED floodlights over traditional floodlights can save you about 0.5 liters or 0.13 gallons per hour. You get the same lighting level with less power. Also, the LED lights tend to last longer, so they are economically and ecologically better ones. And they can also be switched on and off without delays, enabling the shutdown when idling, waiting for the next job and things like that. So it's further lowering the energy consumption. Regarding the power sources, you have several options. Traditional constant speed generator running all time with full speed, even if the crane is not if the crane is waiting for the next job. Actually, it's just standing still. So, but the more eco-efficient way is to apply a variable speed generator, which runs at optimal RPM based on the needed power. So if you are lifting a heavy load, the generator is at full speed. And if you're idling, waiting for the next job, it's also the engine is idling, so saving fuel. So the potential saving between the variable speed generator and the constant speed generator is about 2.5 liters, 0.66 gallons per hour in favor of the variable speed generator. A big money and environmental effect as well. This is a very interesting option. The optimized variable speed engine versus the full-size variable speed engine. If we choose a bit smaller engine, we can have much lower consumption and emissions. Traditionally, the RTG engines have been 15 to 16 liter engines with about 400, 500 kilowatts power rating. However, the full power is very seldom needed. It's theoretically needed only when the hoist and trolley acceleration peaks with full load, like 40 tons, happens simultaneously. And that happens really, really rarely. And it's quite questionable actually if the power unit should be dimensioned according to that let's say a rare occasion. So to enable the using the smaller engine, we just need to cut down the performance just a little bit in case of these very rare extreme conditions and cut the high power demand. As a reference, the RTG average power consumption is around 30 to 40 kilowatts, depending on the operation. So the 400, 500 kilowatt engine is quite a big one for that consumption. The potential saving, it's really remarkable. It's like 3 liters or 0.79 gallons per hour. So really big impact. The battery hybrid. Battery hybrid comes with the battery pack charged by a small diesel engine. So the battery pack is always the main source of energy, and all the RTG motions are fully powered by the battery only. And the engine is running only if needed to recharge the battery. And therefore there is no idling for the diesel engine, which affects the fuel economy quite a lot. Also, the batteries are used for storing the regenerative energy. So every time you lower the container, the generated energy goes to the batteries. The battery hybrid can provide full performance equal to large diesel generators, and therefore the saving we are showing here, 5.5 liters or 1.75 gallons per hour, is compared with the VSG, the variable speed generator in this presentation. So like apples to apples. Okay, so here is like a summary of the design issues I just went through. The crane weight can have an effect of 0.5 liters or 0.13 gallons per hour. The all-electric design, 2 liters or 0.5 gallons. The weight of the spreader, 1 liter, 0.26 gallons. The lighting setup, 0.5 liters, 0.13 gallons. Choosing the variable speed generator in lieu of a constant speed generator can save you 2.5 liters or 0.66 gallons. And opting for an optimized VSG engine instead of this full-size VSG can save you further 3 liters or 0.79 gallons. And the battery hybrid is about 5.5 liters or 1.45 gallons compared to the VSG. So the total potential sums up to about 12 liters or 3.17 gallons Of course, these are indicative figures, and depending a lot of the local conditions, number of container moves and lifted loads and heights, and how much gantry do, how much shuffling and things like that. But these are like very good average figures to consider and compare. The first 4 points also apply for the E-RTGs, the main supply RTGs, and lower their energy consumption. So the weight, the electricity, the weight of the spreader and lighting and things like that. In the past slides, we went through quite a lot of alternative ways to influence the eco-efficiency of RTG crane operation. If you found yourself interested in any or some of the features, we have taken them into consideration in our crane design, and they are available in our RTG offering. So let's take a look at our offering and energy alternatives there. So we have the zero emission RTG, which is the E-RTG or main supplied RTG, then the hybrid RTG, smart power RTG, and classic RTG, which comes in either constant speed or variable speed genset. Starting with the zero emission RTG then. Zero emission RTG comes with either a cable reel or bus bar supply, and the bus bar supply can be manual or drive-in type. As you can see, there's a lot of voltage alternatives there as well. In many cases, the zero emission RTG is very, very cost efficient and very, very eco-efficient alternative with about 3 kilowatt-hour energy consumption per move, or 30 to 40 kilowatt-hours in an hour of operation. Typically, there is still a small diesel generator set to provide the energy for the stack changes, and then some have even a full genset as a backup. But there is an alternative for the auxiliary generator, and I will come back to that a bit later. The second power source alternative we have is the battery hybrid, with a huge potential for fuel and emission savings. Typical consumption being about 6 liters per hour, meaning even 12 liters saving compared to the conventional RTGs. I will go through the, let's say, hybrid option a bit later in this webinar in more detail. So let's not go into details here. Then the smart power RTG. This comes with the lowest fuel consumption in the market without energy storage. Typically 9 liters per hour, providing even 9 liters savings per hour. It has the smaller diesel generator and intelligent power management system. As I mentioned earlier in this presentation or webinar, the peak powers are limited to enable the smaller engine and lower consumption. The limitation doesn't have any noticeable effect on the average RTG operational performance. So very, very interesting choice. Then the Kalmar Classic RTG. That is available with either constant speed or variable speed generator. Its diesel is always sized according to the peak load, providing the full performance at all times. It's typically equipped with a 15 to 16 liter diesel engines. In variable speed generators, the engine RPMs are adjusted according to the lifted load to provide the best fuel economy, but still full performance. The typical fuel consumption of a variable speed generator is about 12 liters per hour, compared to conventional RTGs. Okay, this is like a summary of the previous slides. So showing the typical fuel consumption figures of all the previously mentioned RTG types, starting from the hybrid RTG to smart power classic RTGs. So ranging from just above 6 liters to 15 liters. This shows the typical emission savings of the power supply options. Naturally, the zero emission RTG with cable reel or bus power supply can provide zero local emissions. The second generation battery hybrid emissions are only 36% of the emissions of the conventional RTG, in other words, providing over 60% emission reduction, and so forth. A lot of choices here. Within Kalmar, we have this group called Terminal Design Services that can help you actually with finding the best possible option for your specific case. Normally, it requires a closer study to get familiar with your operation. Finally, the terminal design services can make terminal layouts, operational calculations, business case validations, simulations, and such. Just contact your local Kalmar contact, and they will help you in arranging such studies. We will help you with this one. Then next, let's take a closer look at the Kalmar hybrid RTG. Currently, we have the second hybrid generation in our offering. I will go through and explain the benefits in more detail in the coming slides, but they are here. The lower operating costs, maintenance costs, emissions, noise, and hybrid also maintains the full operational flexibility regarding the block changes, for example, and the full performance. So no compromises there. Just to refresh the memory, this is the same, more or less the same slides shown earlier, but when we talk about hybrid, we talk about 6.5 liters per hour and about 60% emission reduction per year. Then about the maintenance reduction. Since the engine is running far less than with the conventional full-size power unit, the maintenance intervals are much longer because the engine is running only during the charging cycle, not all the time. And furthermore, no maintenance is needed on the battery pack, just checkups. The same goes with the noise reduction. The engine is running far less than with conventional full-size power units, and the engine is much smaller, so less noise. There are certain markets where the battery hybrid is a especially attractive eco-efficient option for zero-emission RTG. And these are areas where the electricity network is not reliable, or existing terminals with lack of space for cable reel or bus bar installations. Let's check these on the coming slides a bit more in detail. So, hybrid RTG is not affected by electrical grid quality. of course, not connected to the grid. So some countries, the quality and reliability of the electricity is poor. And as an indication of this one, 40% of our zero-emission RTGs delivered have full-size diesel generator as backup for the electrical supply. So that really tells that not all customers can rely on the electricity supply alone. Then the hybrid RTGs, you don't need any infrastructure, as is the case with the zero-emission RTGs with cable reel or bus bar supply. And in some existing terminals, there may be space issues with fitting the cable reels or bus bars, and therefore the hybrid is an attractive option as well. Okay, I think we pretty much covered this already, but let's do it again. So the battery pack is the main source for energy. All motions on the RTG are fully powered by the battery, and engine is running only if needed to recharge the battery. And the batteries are also used for storing regenerative energy. So every time the container is lowered, the energy is fed to the battery packs, saving fuel. Here are the main components of the battery hybrid. On the left-hand side, you see the battery housing, below front sill beam and electrical equipment house. So that is like a walk-in type solution. On the right picture, you see the battery modules which are inside this housing. And in the middle picture, you see the small diesel generator under the rear sill beam, which is also in a convenient place, in a let's say walk-in from the ground level. Well, you don't really walk in, but you can maintain it from the ground level. Then about the battery life, the theoretical design life of the battery is more than 8 years, and we give a warranty of 5 years on the battery modules. Well, if something goes wrong with the battery pack, first of all, the single battery modules can be replaced. And then the onboard diesel generator can be used as an emergency supply. So the RTG can be driven from stack for maintenance if needed. And here is the list of the movements or functions that are supplied with the onboard diesel generator. So wheel turning, gantry motors, empty spreader, full load with limited speeds, working lights, power sockets, air conditioning units, twist locks, trolley traveling, things like that. So really an emergency operation. So that was about the hybrid. But the batteries can also be used for E-RTGs, for zero-emission RTGs. So Kalmar has recently launched the zero-emission RTG with battery pack. Typically, the cable reel or bus bar RTGs have an auxiliary generator for stack changes when the crane is disconnected from the main supply. But equipping the RTG with a small battery pack, the crane can move from stack to stack without need for diesel engine. The benefits quite obvious. So no zero emissions locally as there is no diesel engine. Then because no diesel engine, the energy costs are lower, the noise is much lower, you get the time and cost gains from a maintenance perspective as no diesel engine to maintain. no need to refueling, availability improved, and so forth. And one specification item, with a fully charged battery, the crane can travel up to 1.5 kilometers between the stacks as a standard configuration. Okay, as last part of this webinar, we have a customer case to present for you for the battery hybrid, and that is Exogun in Argentina, which I'm very happy and proud to present. Always happy to present a happy customer. The cooperation between Kalmar and Exogun started actually already somewhere in 1997 with an order for 6 Sisu RTGs. Our RTGs were branded Sisu back then, and those are still operating. And actually myself, I was a fresh sales support engineer at our Tampere factory in Finland, and I remember being involved in the preparation of the solution for Exogun together with our local team. So warm memories from there. Also this time our local team has made a good work together with the customer, going through all the alternatives available. And at the end, Exogun chose hybrid RTGs. And now they have 4 hybrid RTG in operation and 2 more on order. So let's see what we learned from them. One of the reasons Exogun chose hybrid RTGs was that they were able to make the operations cleaner, reducing the emissions without making any significant changes in their operational model or infrastructure. In other words, it was easy and cost efficient. The E-RTGs were also considered, but like in many other cases, electrical supply network in their region is not stable, and therefore the electrification was not an option for them. The new hybrid RTGs have had a big economical and environmental effect on their operation, as you can see. So their fuel consumption has gone down from 12 to 13 liters per hour to just over 5 liters or 1.4 gallons on average on the 4 cranes. So really big drop on the emissions and fuel costs. A big achievement there, without then making any changes on the operational structure or infrastructure or anything like that. Also, the lower maintenance costs have been notified by Exogun. So they feel that the hybrid solution helps them to cut the maintenance costs because of the simpler design of the crane and few parts. This was more or less all about the Exogun case I had prepared for this webinar. I hope you found it interesting. We had spent actually quite a lot of time talking with Exogun to understand their needs, especially regarding the fuel savings and emissions. We came to the conclusion that the hybrid solutions could help them to achieve their objectives. This kind of constant dialogue with the customer is really important part of our work and how we like to do the work. If you like to see it, there is also more information about this Exogun case in our Kalmar website, kalmarglobal.com. You may also want to check that one. There is also a nice video with customer interviews. Now it's time maybe to summarize the webinar before the Q&A session. So the basic crane design, has a major effect on the eco efficiency. That we learned, including the crane and spreader weight, all electrics versus hydraulics, and lighting solutions, and so forth. The various power source alternatives for different operating environments, including large and small size variable speed generators. So lots of power source alternatives. The hybrid RTG provides savings, maintaining the performance and mobility. There are some special markets for hybrid RTGs. Areas where electrical supply quality is bad, or there's no space for electrification in the existing terminals. And then we introduced the zero emission RTG with battery pack. So no auxiliary diesel needed, no local emissions. And finally, the hybrid case Exogun learned that it was the perfect eco-efficient choice for Exogun. They operate currently with an average of 5 liters per hour compared to the 12 to 14 liters earlier, with no changes on the operating model or infrastructure. Okay, now it's time for the Q&A session. You can still post questions using the chat window in the right part of the screen. So let's see if we have any questions here. Let me see. Okay, one is the smart RTG similar to VSG RTG? Yes, the smart power RTG is very similar to VSG RTG, but having a smaller variable speed generator with the let's say smart power management system to control the power usage. Then okay, one question here. How long does the diesel engine run in an hour in hybrid RTG? Well, I guess that's a lot depending on the operation, but let's say from experience, I would say that it runs typically like from 30 to 60% of operating time, meaning that if the operating time is like 10 hours, then the engine would be running like 3 to 6 hours of that time. Okay, let me see. All right, another one for hybrid. With hybrid RTG, how long can you run with the full battery without the engine running? Like the previous question, I mean, it depends a lot on the operation, but maybe in 1 hour, maybe 1 hour is quite close to the average. Okay. Then what engine size? What engine size are you using for the battery hybrid? Yeah, that one is easy. Typically, we are using like 5-liter engines Okay, what else? As Kalmar, what are the developments about wireless charging of batteries without cable connection, charging from ground level? At the moment, we don't have such technology available for the RTGs. For the travel carriers, we are using fast charging, but not really from this wireless charging, at least not yet. Okay, then there's a question that how many years has Kalmar been delivering hybrid machines, including Strat, shuttles, and RTGs? Well, that is a long history. We started hybrid deliveries somewhere 2009 or 8 or 9, something like that. So really long time ago. And there are like over 300 machines up and running at the moment. Okay, what else? One is that you mentioned about lower maintenance cost of hybrid RTG. In what sense? Engine maintenance? Yeah, exactly. The engine maintenance is lower as it runs far less per operating hour than the normal engine generator set, only when charging the batteries. So that's pretty clear. Any other? Wire rope is important or not important for this design? I guess the wire rope setup is not that much relevant to fuel consumption or eco-efficiency there. Any other? I guess there's no any, not coming more questions there. Yeah, one is there. The life of an RTG is in excess of 8 years. Considering worst case of full battery replacement after 8 years, is the overall maintenance cost over, let's say, 15 years lower than E-Series RTG? Well, that's a very tricky question. I guess that needs to be taken into consideration, the whole thing with all the operational details. So I would not answer this one right away. So need to be a little bit, let's say, more details on that one, how to formulate an answer for that one. Okay, I think. All right. One question. I was just about to say that we don't have any questions anymore, but just one came up. So can you say how many RTGs is working on the world? Yes, sure. It's well, it's more than 1,000. Can't remember the exact figures, but well over 1,000. Yeah. Okay. Very good. As it looks that we have answered all the coming questions, it's time to thank you all for joining the webinar. If you happen to have any further questions, just contact myself on my email address, markorasinen@kalmarglobal.com. So please just ask. Thank you. We will now close the session.